Alright, hey there, this is Garth, and I wanted to give a physics example of how to solve for the angular momentum of a 15,000 RPM spinning hard drive. Um, so just to start off, here are a couple of formulas. So we have the angular momentum formula, um, which is equal to the moment of inertia, I, times the angular velocity, W. We've got that illustrated here. We have the moment of inertia, I. That's also equal to the mass times the radius squared. And so if we substitute that into our equation, we now have our angular momentum is equal to our mass times our radius squared times our angular velocity. So now we want to find each of these terms. So we can start out and find the angular velocity W. That is the change in theta over change in time. So W equals d theta over d time. An important thing to note is hard drive spin in revolutions per minute. So 15,000 revolutions per minute, we need to convert that to radians per minute. So that's 2 pi times 15,000. So we get about 94,000 radians per minute. Divide that by 60 and we get about 1,500 radians per second. Now if you want, on the side, while we're doing this, we could divide this by the amount of time it takes a hard drive to spin up. Most hard drives take about 5 to 10 seconds to spin up. So if we say 7 seconds on average, and we divide that, our 1,571 radians per second, which is our angular velocity, and then divide that by our change in time, we get about 224 radians per second for our angular acceleration. Now, continuing back onto the main problem, we want to find the mass now. So we've got our angular velocity W. We need the mass. So I tried Googling this. I can't easily find the mass of a hard drive platter. You can find them on eBay. There are several stacks of them, and people weigh them on a scale and take a picture of them, but I didn't want to count them. So I figured I'd go ahead and calculate them. So modern hard drives and desktops, they usually have a radius of about 1.5 inches. So if we convert that to meters, we get this quantity. And the thickness of a hard drive's spinning platter is about 1 millimeter. So we can solve for the volume of a cylinder as pi times the radius squared times the height. And we get about 4.6 times 10 to the negative 10th cubic meters volume in a hard drive spinning platter. So that's the volume of the spinning platter. And we know that hard drive platters are mostly made up of glass, and that weighs about 2,270 kilograms per cubic meter. So if we go ahead and multiply that out, we get our mass of a hard drive spinning platter, which happens to be 1.04 times 10 to the negative 6th kilograms. So now we've got our mass, we've got our radius in meters, and we've got our angular velocity in radians per second. So we can go ahead and plug all of these in and get our angular momentum. So for our final solution, we plug each of our terms in, and our angular momentum happens to be 6.22 times 10 to the negative 7th power kilogram meters squared per second.